Hi, this is Suresh. Welcome to Rock Tutors. Today we are going to discuss new chapter, Refraction Through a Lens, Class 10th ICSE Board Physics. In this chapter, we will discuss about lens and some technical terms related to lens and refraction light through the lens. And also we will do a small activity based on refraction of light through prism and glass slab also. ఈరోజు మనము ICSE బోర్డ్ ఫిజిక్స్ 10th క్లాస్లోని రిఫ్రాక్షన్ త్రూ ఏ లెన్స్ అనే చాప్టర్ గురించి డిస్కస్ చేసుకుందాము. ఈ యొక్క వీడియోలో మనము లెన్స్ అంటే ఏంటి, లెన్స్కి సంబంధించిన కొన్ని టెక్నికల్ టర్మ్స్, అలాగే ఒక చిన్న యాక్టివిటీ మనం చూద్దాం. ఆ యాక్టివిటీ ఏంటంటే రిఫ్రాక్షన్ త్రూ ద ప్రిజం అండ్ గ్లాస్ స్లాబ్. అంటే లైట్ కనుక గ్లాస్ స్లాబ్ నుంచి వెళ్తున్నప్పుడు లేక ప్రిజం నుంచి వెళ్తున్నప్పుడు అది ఏ విధంగా బిహేవ్ చేస్తుంది అనే దాని గురించి దాని మీద విల్ డూ వన్ ఎక్స్పెరిమెంట్, వన్ యాక్టివిటీ. So please don't skip this video. This video will help you to understand the concepts of this topic. This topic is very important and very easy and also interesting. We will discuss this chapter into as a 3 parts. Now this is the first part of this lesson, and we will do 2 more sessions on this chapter. So please don't skip this video, and for more updates please like, share and subscribe. Now without delay we'll go into the topic. Our topic, refraction through a lens. So this chapter is divided into 3 parts. The first part is lens, refraction of light through a lens. In this topic, so what is mean by lens? Lens ante ఏమిటి? Lens is a transparent and refractive medium bounded by either 2 spherical surfaces or one surface is spherical, another surface plane. This is about lens. Now here talking about that one surface is a plane, means plane also is a part of the sphere. Plane also is part of the sphere. Yeah. Next point, next sub point is a kind of lenses. Lenses are mainly 2 kinds. One is that converging or convex lens. Another one is a diverging or concave lens. We'll see what is meant by convex lens. So convex lens, a lens is that if you see in this diagram, this is a convex lens. So here in this convex lens, the middle portion, the middle part is a thick. This is thick. And if you go into the edges called a periphery also. So going to edges, this is thin. So this type of lens is called a convex lens. So here the 2 surfaces are కాన్వెక్స్ సర్ఫేసెస్. సో ఇక్కడ మనము ఇలా చూస్తే ఈ యొక్క కాన్వెక్స్ లెన్స్ చూస్తే ఇక్కడ మధ్యలో థిక్గా ఉంది. సో ఇక్కడ ఎడ్జెస్ కమింగ్ టు ద అంటే మనం కనుక ఈ చివరికి వస్తే ఎలా ఉంది, ఇవి చాలా థిన్గా ఉంది. సో నా దీన్ని ఏమంటామంటే కాన్వెక్స్ లెన్స్ అంటాం. సో కాన్కేవ్ లెన్స్, see here, if you observe, in this one, in the middle portion, it is a thin. If you coming towards the edges, it is a thick. This type of lens is called a concave lens or diverging lens. సో ఈ యొక్క డైవర్జింగ్ లేకపోతే ఇది కన్వర్జింగ్ అని ఎందుకు అంటాము? వై వి కాల్ దీస్ లెన్సెస్ ఆర్ ఏ దిస్ ఇస్ ఎ కన్వర్జింగ్, దిస్ ఇస్ డైవర్జింగ్. వై వి కాల్ దిస్ a converging diverging? We'll see in the topic. Now this is the mainly two kinds. ఈ యొక్క కాన్వెక్స్ లెన్స్ లో అలాగే కాన్కేవ్ లెన్స్ కూడా మళ్ళీ ఇంకా 3 రకాలైన యొక్క లెన్స్లు ఉంటాయి. దానిలో కాన్వెక్స్ లెన్స్ గురించి డిస్కస్ చేసుకుందాం. కాన్వెక్స్ లెన్స్ లో 3 రకాలు. There are 3 types in a convex lens. One is that biconvex. What is that? Biconvex, double convex or equiconvex. Biconvex అంటే ఈ యొక్క లెన్స్ లో, ఇన్ దిస్ లెన్స్ ఈ 2 సర్ఫేస్లు కనుక కాన్వెక్స్ సర్ఫేస్లు అయితే, ఇఫ్ దిస్ లెన్స్, ఇఫ్ 2 సర్ఫేసెస్ ఆర్ కాన్వెక్స్ సర్ఫేసెస్, then this is called a biconvex lens. Second type, plano-convex, means one surface is plane, another surface is a convex surface. ఇలాగంటే అంటే ఒక సర్ఫేస్ ప్లేన్ గా ఉండి ఇంకొక సర్ఫేస్ కనుక కాన్వెక్స్ సర్ఫేస్ అయితే అప్పుడు దీన్ని ప్లానో కాన్వెక్స్ లెన్స్ అంటాం. వాట్ వి కాల్ దిస్ ఇస్ ఎ ప్లానో కాన్వెక్స్ lens. Why? Because this is one surface is plane, another surface is a convex surface. So this is called a plano-convex. Third type, concavo-convex lens. Concavo means one surface is a concave surface, another is a convex surface. సో దీన్ని ఏమంటామంటే ఇలాగ అనుకుంటే ఒక సర్ఫేస్ కాన్కేవ్ సర్ఫేస్, ఇంకో సర్ఫేస్ కనుక కాన్వెక్స్ సర్ఫేస్ అయి ఉంటే ఈ లెన్స్ ని కాన్కేవో కాన్వెక్స్ లెన్స్ అంటాం. అలాగే కాన్కేవ్ లెన్స్ లో కూడా 3 రకాలు ఉన్నాయి. సో ఫస్ట్ వన్ ఈజ్ దాట్ ఏంటంటే biconcave, double concave or equiconcave lens. ఇక్కడ చూస్తే మనకి ఈ 2 సర్ఫేస్లు ఎలా ఉన్నాయంటే కాన్కేవ్ సర్ఫేస్లు, అందుకనే దీని అంటామంటే బై కాన్కేవ్ ఆర్ డబుల్ కాన్కేవ్ ఆర్ కాన్కేవ్ లెన్స్లు అంటాం. ఇంకొకటి ప్లానో కాన్కేవ్, సెకండ్ టైప్. Plano means similar. దీనిలాగే this is one is a plane surface, another is a concave surface. This is called a plano concave surface. So దీనిలో కూడా third type is a convexo and concave. Convexo concave అంటే ఫస్ట్ కాన్వెక్స్ సర్ఫేస్, అలాగే దెన్ కాన్కేవ్ సర్ఫేస్. దీని ఏమంటే కాన్వెక్స్ కాన్కేవ్ లెన్స్ అంటాం. యాక్షన్ ఆఫ్ ఎ లెన్స్ as a set of prism. Action of a lens, a set of prism. అంటే ఏంటి? If you observe the lens మనం గమనిస్తే, if you observe the lens, ఈ యొక్క లెన్స్ లో దిస్ పార్ట్ అండ్ దిస్ పార్ట్ చూడండి ఎలా ఉందో. ఇది ఒక ప్రిజం లాగా ఉంది, ఇది కూడా ఒక ప్రిజం లాగా ఉంది. And the middle part, a middle portion is looks like a rectangular glass slab laga undi. Now this is a prism, this is also prism, this is a glass slab. Ikkada chuste concave lens lo gan gamaniste, if you observe in a concave lens also, here this portion and this portion. So this portion is a prism, this portion also prism, and this portion looks like a glass slab, rectangular glass slab. So we can say that lens is a combination of prism and a glass slab. అంటే మనము దీన్ని బట్టి ఏం చెప్పొచ్చు అంటే, ఏమర్థమైందంటే లెన్స్ అనేది ప్రిజము మరియు గ్లాస్ ల్యాబ్ యొక్క కాంబినేషన్ తోటి ఫామ్ అవుతుంది. సో ఇది ప్రిజం. ఈ యొక్క ప్రిజంలో ఈ బాటమ్ దీన్ని ఏమంటే బేస్ ఆఫ్ ద ప్రిజం అంటాం. ఏమంటాము? బేస్ ఆఫ్ ద ప్రిజం అంటాం. బేస్ ఆఫ్ ద ప్రిజం. కన్వర్జెంట్ యాక్షన్ ఆఫ్ ఏ కాన్వెక్స్ లెన్స్, దాని గురించి డిస్కస్ చేసే ముందు మనం చిన్న యాక్టివిటీ చేద్దాము. ఆ యాక్టివిటీ ద్వారా ఈ యొక్క పాయింట్ని మనము అర్థం చేసుకోవచ్చు. యూ కెన్ అండర్స్టాండ్ convergent action of a convex lens by doing activity. So we can understand this concept very easily. So now I will do as activity. Please carefully observe. In this activity, I am taking a prism. This is a light ray falling on the prism. If you observe here, this is incident ray, this is refracted ray, and this ray is a emergent ray. If you observe in this activity, this emergent ray is bended towards the base. Here is the base. It's bended towards the base. If I turn this prism, now base is on the top. Now see, this is incident ray, this is the refracted ray, and this is emergent ray. This emergent ray, we can see that it is bended towards the base. it is clear. So when the light is passing through the prism, after refraction, it bends towards the base of the prism. You can see one more prism. If I change, yeah. Now see here, this is the base of the prism, and this the light is refracted and emergent, and here this emergent ray is bended towards the base of the prism. If I turn this prism, the base is going up, and now see here. Here also this ray is incident here and refracted and is came out, and this emergent ray is bended towards the base. So whenever the light is passing through the prism, then after refraction it will be bends towards the base. That is, we observe in this activity. So now one more activity, you'll see here, if the light is passing through a glass slab, what happens? So I'm taking a glass slab. Yeah, this is a glass slab. Now see here, this is the incident ray, this is a refracted ray, refracted inside the glass slab, and it is coming out. This is emergent ray. And we know that this activity will learn lateral shift. I will explain now how it is a lateral shift happens and what is meant by lateral shift. Okay. Now here this is happening here also. The light is refracted, and here this incident ray, this is a emergent ray. These both are parallel. So this incident ray and this emergent ray both are parallel. We'll see now. So this is the way when light is passing through the prism or a glass slab, what happens, how it is refracted, we saw here. Now we'll apply these points, this concept to our lens, then we can understand more clear about the convergent and divergent of the lenses. Just now we observed that in that activity, light is when passing through the prism, this is the light, incident light, this incident, and after refraction it is coming out, emergent ray. This emergent ray, so this is the base of the prism, and after emergent, this ray is bended towards the base. This one we did in an activity, we observed also. Another point here, this is a glass slab. In the glass slab, if light is incident here, if I draw the normal, this is a normal. We know that this is a air, this is a glass slab, this is a rarer medium, this is a denser medium. When light is passing, this is a rarer medium, this is a denser medium. When light is passing through rarer medium to denser medium, we know that the light will be bends towards the normal. This ray, actually this ray has to be, if there is no glass slab, this is the path of the ray. But it is entering into the denser medium, it bends towards the normal. This is the normal. It bends towards the normal. That means it will be moves like this. Yeah. Now here this is the denser medium. Now it is coming out into the air, means rarer medium. So when denser to rarer, what happens? Then this, if I draw here normal, actually this ray has to go like this. But we know that when light is entering into a denser to rarer, it will be bent away from the normal. This is the normal, this is the actual path, and will bend away from normal. That means like this. It is coming like this. So if you observe here, this is the incident ray, this is the emergent ray. These both are parallel. Now that means, so incident ray and emergent ray both are parallel. So here, this perpendicular distance from here to here, the perpendicular distance, this is called a lateral shift. What we call? This is called a lateral shift. Now lateral shift is depends upon the width of the glass slab. The glass slab width is decreasing. The glass slab width is decreasing. What happens? Then this, the lateral shift also, it will be decreases. So this will be, it will be closer to here. If the glass slab I will decrease more, then this length also, this lateral shift also will be decreases. If this glass slab is very thin, so what happens? If the glass slab is very thin, like this, now this light is, so that lateral shift also, it's very almost very close. It is looks like there is no deviation of the light. So we know that when we are using the lenses is not this much of thick, they are very thin lenses. So in that one, when the light is passing through the thin lenses, what happens? You can observe that. So there is no deviation. So it appears that the light is moving in a straight line without any deviation. It appears. It's that the deviation, that lateral shift is negligible. Okay, now, so we apply these points, we apply to our lenses, we see that what will happen. What action? Now, here, this is the lens, this is a convex lens. Yeah. So when light is falling on the surface, you know that just now we observe that on a prism, when light is falling on the prism, so what happened? After refraction, this light is like this, coming like this, bended towards the base. This is the base towards the base. Now, same way, the light is falling on this portion. We know that. So this will be, so bends towards the base. This is the base. So here this is the base and bends towards the base. So what we observe here, the rays are passing through the lens. After refraction, they are meeting a point. They are coming like this. So this is called a converging. So after refraction, the rays are converging. That's why this lens is called a converging lens. Understood why we call this a converging lens? Why? Because the rays after refraction, they are meeting a point, so they are converged. The rays are converged and they are meeting. So this is, that's why this is called a converging lens. Why is converging? See here, this is the reason. Why? Because the top portion is behaves like a prism and the bottom portion also behaves like a prism. In the prism, we observe that the lights after refraction, they will bend towards the base. So here, this base is here, this base is here. That's why these rays are bending and is coming like this. That's why this lens is called a converging lens. So what is the divergent action? See here. This is a concave lens. You know that this portion and this portion. This is a prism, this is a prism. Then the light is falling on this one. So this is the base of the prism. Here the base of the prism, this is also base of the prism. Now we know that when light is passing through the prism, it bends towards the base. This is the base. So it will be after refracted, it will bend like this. Here also the light is falling on here, incident on this portion, and we know that this is a base and will be bends towards the base. Yeah. Now what we observe here, in this one, after refraction, the rays are diverged. They are moving away each other. So they are diverging. That's why this is called a diverging lens. మనం గమనిస్తే ఇక్కడ రేస్ ఒక లైట్ బీమ్ ఇక్కడ చూస్తే రిఫ్రాక్షన్ అయిన తర్వాత అని చూసాం యాక్టివిటీలో. సో లైట్ కనుక రిఫ్రాక్షన్ అయిన తర్వాత ఏమవుతుందంటే అది ప్రిజం యొక్క బేస్ వైపు బెండ్ అవుతుందని చూసి మనం గమనించాం. ఇక్కడ కూడా ఈ రే వచ్చిన తర్వాత ఇలా ఇన్సిడెంట్ అయితే రిఫ్రాక్షన్ తర్వాత ఈ లైట్ ఈ రే అనేది బేస్ వైపు బెండ్ అవుతుంది. ఇలాగా రెండు రేసు ఒకదానికి ఒకటి ఇలాగా దూరంగా వెళ్తున్నాయి కాబట్టి దీని ఏంటంటే డైవర్జింగ్ అంటాం. సో దిస్ లెన్స్ ఈజ్ కాల్డ్ ఏ డైవర్జింగ్ లెన్స్. Some technical terms related to lens. Now, first point is a center of curvature. Center of curvature. Now, this is the lens. This is a convex lens. This surface is a part of the sphere. Yeah. This surface is a part of the sphere. This sphere has a center and it is a C1. మనం గమనిస్తే ఈ యొక్క సర్ఫేస్, ఈ కర్వ్డ్ సర్ఫేస్ అనేది స్పియర్ యొక్క పార్ట్. స్పియర్ ని కట్ చేస్తే నాకు ఈ పార్ట్ వచ్చింది. If you cut the sphere, this is a part. This means this part is a part of the sphere. Now, this is the center of the sphere. This is called a center of the sphere. Now, this center, this is the same center is the first center of this curvature also, this curve also. That's why this is called a center of curvature. So, this is the part of, this curve is a part of the same surface, same sphere. This part, this curve is the part of the same sphere. That's why this center is called a center of curvature. Now here, for this curve also, this also is a part of a sphere, hollow sphere. So now this sphere also has a center, C2. Now this center is a center of sphere and this curve is a part of this sphere. That's why this center is called a center of curvature. And same way for concave also. For concave, this surface is a part of a sphere. This surface also part of the sphere. Now this sphere has a center and this is a, you can see C1, and this sphere also has a center, this is C2. Now this C1, this curve is a part of this sphere. That's why here also C1 is called a center of curvature. Here also same way, This curve is a part of this sphere, and this center is called the center of this curvature. This is called the center of curvatures. Next, radius of curvature. This curve is a part of this sphere. This sphere has a center, just now we discussed, and the radius, this is radius of the sphere. This is radius of the sphere. Now, this radius of the sphere, this curve is a part of this sphere, and this radius is called a radius of curvature. This I am taking as a R1. Here also, this curve also part of a sphere, and this sphere also has a center C2, and the radius, this sphere also has a radius, and this is a R2. Now here, if both spheres have equal surface, equal radius, that means here, if R1 is equal to R2, if R1 is equal to R2, then this length is called a, now see, I am cutting this part. Yeah. Now this length is called a equiconvex lens. Equiconvex lens means what? If the equiconvex lens means what? If the radius of curvatures of both surfaces are same, equal, then this convex lens is called a equiconvex lens. If these radius of curvatures are not equal, suppose R1 is not equal to R2, then this convex lens is called a biconvex lens. There is a difference between biconvex lens and equiconvex lens. Equiconvex lens means, so their radius of curvatures R1 is equal to R2, then this is called a equiconvex lens. Otherwise, it is called a biconvex lens. Equiconvex lens you can call as a biconvex lens also, both the same. But biconvex lens may not be equiconvex lens. The same way, here also, for concave lens, this surface is a part of the sphere. This surface is a part of the sphere. This sphere has a center C1. Now this surface also part of the sphere. Now this also has center C2. Now from the radius of this sphere is called a radius of the sphere. This curve is this surface is the part of this sphere is called a radius of curvature. This is a C1 from here to here. From here to here, that becomes R1. So this is R2. For this is a part of the sphere. This curve is part of the sphere. This sphere has a radius is R2. Now, so this curve also has the same radius R2. So this radius is called a radius of curvature. Now here also, if R1 is equal to R2, then this lens is called a equiconcave lens. This is called a equiconcave lens. If I cutting this edge, this part, this portion, and this is the equiconcave lens. If R1 is not equal to R2, R1 not equal to R2, then this is called a biconcave lens or double concave lens. Next one, principal axis. What is the principal axis? So here, just now we saw that lens has a two center of curvatures. For this portion, this curve has center curvature C1. For this curve, center curvature is the C2. And an imaginary line passing through these two center of curvatures, that line is called a principal axis. Now here, this line, this is imaginary line passing through two center of curvatures. So this line is called a principal axis. Next point. Now here also same. For this, for concave lens. For concave lens. So for this is a C1 and C2. If I am joining a line passing through C1 and C2, so this line is called a principal axis. Okay. So next point, optical center. What is meant by optical center? Geometrical center of the lens. That means, so here, this is center. It's called a optical center. For here also, this is a optical center. By what is the actual definition? How we can say what is meant by the optical center? Optical center means, here just now we discussed, we saw in an activity also, this is a prism and this is a glass slab. So you think that this is a thin glass slab. This is very thin glass slab. So what happens when the light is passing through the glass slab? When the light is passing through the glass slab, incident passing through the glass slab, if it is passing through a particular point from here, if the ray is not deviated, it going straight, then this point is called a optical center. This ray is passing through this point. So without deviation, it's moving. This line is passing through this point, and without deviation is coming. Now this point is called a optical center. That means through which point the ray is passing, through which point the ray is not deviated, the ray is undeviated, is moving straight. So that point is called a optical center. For here also, for concave lens also, the ray is passing through like this, through this point, the light is passing through this point. If that light is without deviation, this light is passing through without deviation, then this point is called a optical center. Now here also like this. This point is a optical center. So generally this optical center is a center of the lens, geometrical center of the lens. That's right. So we denote it with O, optical center. Here also this O. This is a center of the lens. It's called optical center. When a light ray passing through the optical center, it will, without any deviation, it will be go straight. So when we are doing that, when we are drawing the ray diagrams, that time these points will be help us to draw the ray diagrams. Okay. Next point is principal foci. We know that this is a lens. The rays can be incident both sides, either both sides. This side can also rays can come, and from this side also rays can come. Yes or no? So this lens or the lens rays will be maybe I can so use the rays may be coming from this side or maybe coming from this side. Also you can fall on the either side. So that's why this lens has a two focus. That's why it has this lens has a two foci. See, this is a convex lens, and you know this is a C1, this is C2, this is okay. Now, what is the first focal point? We'll see. First focal point. If a beam of light from here, this point is a beam of light is going like this. After refraction, these rays are parallel to principal axis. These rays are parallel to principal axis. Now, this point is called a first focal point, F1. Now, what is meant by second focal point? Second focal point means the rays are parallel to principal axis, parallel to, so I'll draw here. This is F1, just now we discussed. Now, rays are parallel to principal axis. After refraction, it is meeting on the principal axis. This point is called a second focal point. This is called a second focal point. Here this is the F1, here is the F2. For concave lens, so this is the concave lens. This is C1, this is C2. Now, the rays are coming, it appears coming from a point after refraction parallel to principal axis. After refraction parallel to principal axis, then this point is called a first focal point. This point is called a first focal point. This is a F1. Second focal point this is C1, C2, this is F1 just now we discussed. Now The rays are parallel to principal axis. You know that it appears that from a point, if I extend back side, from a point it appears that they are diverging. They are diverging. From on the principal axis, a particular point, from a point, it appears that rays are diverging. So now this point is called a second focal point, F2, second focal point. So here this is a way the terms meaning of the first focal point and second focal point. Next term is a focal plane. Focal plane means this is a convex lens and this is C1, C2, F1, F2, an imaginary plane passing through focal point and perpendicular to principal axis. So a plane passing through focal point and perpendicular to principal axis. So now this plane is called a focal plane. This is also imaginary line. An imaginary line passing through focal point and perpendicular to principal axis. So this is called a focal plane. So now here also an imaginary line passing through focus and perpendicular to principal axis. This plane is called a focal plane. Now here we have two focal planes. The focal plane passing through the first focal point is called a first focal plane, and this is the focal plane passing through second focal point. So this is called a second focal plane. We have two focal planes. The same way for concave lens also. The principal axis, and this is C2, C1, F1, F2. The first is also a focal plane passing through focal point. Now this plane is called a first focal plane, and here also a focal plane passing through second focal point. Then this focal plane is called a second focal plane for a concave lens. Focal length. Focal length means a distance between optical center to focal point is called a focal length. Now see here, for this concave lens, convex lens, this is the principal axis C1, C2, F1, F2. Now this is the optic center. Optical center is a O. O is the optical center. Now the distance between focal point and the optic center, this distance is called a focal length. From here also, from optical center to focal point, this distance is called also focal length. Now, the focal length between optic center to first focal point is called a first focal length. And here, optical center to second focal point, the distance is called a second focal point, F2. The same way for concave lens also. For concave lens, C1, F2, F1, C2. This is the optic center. The distance between optic center to second focal point, this is called a focal length. This is a F2. Here, the distance between optical center to first focal point is called a focal length. This is a F1. These are the focal lengths for a concave lens and a convex lens. These are, for this is the first focal length, this is the second focal length. For the convex lens, this is the first focal length, this is the second focal length. So these are the some technical terms related to lens. I hope you understood the concept. We'll see in the next video. Have a great day.